All right, we're going to wrap up the idea of combinations and compositions of functions with a little bit of a graphical analysis, if you will. And so this is really going to make sure we really understand what's going on. I know sometimes dealing with all the algebra, as we did in the last couple of videos, you know, simplifying and trying to find the domains and things, is a little tricky, but this will sort of, we will give you sort of a crutch in a way. I have the graphs of two functions. F is the solid line is the graph of the function f, and the dashed line is the graph of the function g. And I'm not concerned with you coming up with formulas for these functions. You can give piecewise defined functions because there's each little segment, if you will, is a different linear function. But that's not what I'm interested in. Okay. Strictly, very quickly, I want us to be able to evaluate compositions and combinations of functions using the graph. And if you remember how we can obtain values for the function given its graph, that's what we're going to be doing here. So let's start with this first one. Evaluate f minus g of negative 4. Well, what we're going to say is, of course, by definition, what is f minus g of 4? That is f of negative 4 minus g of negative 4. So we need to find the output to the function f at negative 4, the output to the function g at negative 4, and then subtract in that order. And that's the result. That's all there is to it. How do we find f of negative 4? Well, we come up here, remember, these are the inputs, right? The x-axis, if you will, the horizontal axis, these are the inputs. The outputs are along the y-axis. So I go to where the input x is negative 4, and for the function f, I go up to the solid line. All right, so this point right here is on the graph, and what's the y-coordinate of that point? 5. That tells me input negative 4, output 5, right? So f of negative 4 is 5. What's g of negative 4? Well, again, go to an input rather of negative 4, and this time go down to the dashed line right there. What's the output for the function g? Negative 3. So what I'm getting is 5 minus a negative 3. Right? Well, what's 5 minus a negative 3? It's positive 8. And there it is. So that's what I want you to do. I don't want you to come up with the formulas for these and, you know, then the formula for this and then evaluate. I just want you to use the graph to quickly get the values, making sure you understand what this means. So what does this mean? This is f slash g. This is f divided by g. And so, all right, it's f of 3 divided by g of 3. So what is f of 3? We go to the input of x equals 3. F is the solid line, so I'm going down. All right. F is 3. The output is negative 3. In the bottom, I've got g of 3. What's g of 3? G of 3 is coming up here equal to 2. And so the answer is just negative 3 halves, or negative 1.5, negative 1.5. Okay, and so you get the idea behind combinations, right? So f plus g, we would be adding the outputs. F times g, we would be multiplying the outputs, and so on. What about compositions? So what does it mean f circle g of negative 1? That's f of g of negative 1. Now what we have to do here is first figure out what's the output to the function g. So first we take negative 1, plug it into g. This is not multiplication, remember. This is not multiplication, f times g. So I need to find out what the output is to g at negative 1, and then plug that into f and find the output. So what is g of negative 1 here? G, remember, is the dashed line. What is g of negative 1? Right there, right? Negative 1, the y-coordinate is 0, right? G of negative 1 is 0. Does everyone see that from the graph? G of negative 1 is 0. And so this quantity here is 0. Again, this is not f times 0. This is f of 0, right? Doesn't make any sense, f times 0. F of 0. So how do I find f of 0? I go back up here. When x is 0, right there, what's the value of f? It's the solid line. We come up. Its value is equal to 3. F of 0 is equal to 3. And that's your answer. So be careful, there's no multiplication. So be careful again, this is not fg of x, or fg of negative 1. If I had fg of negative 1, yeah, you'd be multiplying the two outputs together. What's g circle f of 3? That's g of f of 3. So here I find f of 3. F is the solid line. X is 1, 2, 3. Output, negative 3 again, right? Input 3, output negative 3. So the output is negative 3. Again, this is the output to the function f at 3. And now we take that output negative 3 and we plug it into the function g. So now I need to find out what is g of negative 3. So I come back to the graph here. Negative 3 going down to the graph of g dash line, I get negative 1. Okay, so that's a real quick way that at least shows me that you understand combinations and compositions. Okay, so the last little thing I want to look at is to sort of change things around and go in reverse. Now, this will be very simple, I think, but if you go on to calculus, this will be an important skill, being able to identify what two functions are being composed together to create a new function. Now, there's not a unique answer to these questions, but we are looking for a particular type of composition. And so let's see if we can see what we're thinking about here. So h of x is the function 2 of x plus 1 all cubed. Okay. So when we think about, the composition f with g of x, we sometimes talk about the function g of x being the inner function. It's inside the outer function, which we call f in this case. So the inner function is the function we plug into first. We take that result that we get from the inner function, plug that into the outer function. We get our output. So what would the inner function be in this case? Well, just think, what would you evaluate first? Well, in this expression, you'd have to do what's inside the parentheses, right? And once you compute what's inside the parentheses, then what would you do? You would cube that result, right? So what I'm covering up with my finger, that should be our inner function. Right? Our inner function is 2x plus 1. That's our inner function. F of x is 2x plus 1. What's the outer function? What's the outer function then? Well, the outer function is what we do after we do the 2x plus 1 is what? We cube it. So g of x. Oh, I've totally messed this up. I'm sorry. F of x was my outer function. I said that here. And then I said f of x is my inner function. Okay. Well, that was a big fail. G of x is our inner function. So g of x, I'm sorry, should be equal to 2x plus 1. I'm so sorry. So what's the outer function? Our outer function is the cubing function. So f of x, our outer function, is x cubed. Should label up here, right? This is the inner function, and this is the outer function. Okay. Bottom line is, once you determine your inner and outer, you can go ahead and compose, do f of g of x, and make sure you indeed get this. So if I take f of g of x, I take this output 2x plus 1, stick it in here for x, I'll get 2x plus 1 quantity cubed. And so we've split it up into composition of two functions. Now, there's other ways to do this composition, but I think this makes sense. All right, let's see if we can get this right. Inner function. What's the inner function here? What's the inner function here? Well, what would you do first? You'd do the stuff under the radical, right? The x squared plus 4x. So that's the inner function here. X squared plus 4x. What's the outer function? After you do the x squared plus 4x, what do? You take the square root. So the outer function f of x is the square root of x, which can also be written as what? Remember, x to what power? 1/2. Remember, square root of x is the same as x to the 1/2 power. Now, the last one's a little tricky. Anyone have any idea what you would do here first? Well, I mean, we've got a 1 up top. But I've got to figure out what I'm going to divide divide into 1, right? This is the denominator. So really the inner function, g of x, is going to be 5x minus 3. We divide that into 1, and so what's our outer function? It's just the function 1 over x. Or, that's x to what power? Do you remember? 1 over x is x to the negative 1 power. Same thing. Okay. But this is a skill that you will need to develop and work on, especially in calculus. In calculus we learn about something called the derivative, and one of the rules for finding the derivative involves finding the derivative of a composition of functions. It's called the chain rule. And so it's a good idea to be able to identify both the inner and outer function. So I hope this made sense. If there's questions about it, then please let me know. We can talk about it in our Zoom meetings, or you can send me an email.